Today you will be learning lesson 3.1 on inequalities and their graphs. An inequality is a mathematical sentence or statement formed by placing an inequality symbol between two expressions. That's a vocabulary word, so we're going to highlight it. Okay? There's 4 different inequality symbols we're going to be working with today. Okay? The first one is your less than symbol. Okay? Less than means the number on the left has to be smaller than or less than the number on the right. Okay? Another way you might hear it described is fewer than. Okay? To go along with that, we have less than or equal to, which starts out the same way with that less than symbol, but underneath it, it has one line representing equal to, meaning it could also be that number, right? One of the hardest parts, or one of the most common descriptions for that, that's the most confusing, is at most, and that's why I underline that one, okay? At most, so the number on the left is at most the number on the right, meaning it has to be smaller than or equal to that number, okay? The opposite of less than is greater than, so that one opens up to the left, okay? So the number we're starting with, or the expression we're starting with, is bigger than or more than the number we're ending with, okay? Same thing to go with that, there's the greater than or equal to symbol, which means what we started with can be greater than or exactly the same as what's on the right, okay? The most common and difficult descriptor for that one is at least, okay? What we have is at least this much. So the difference between inequality and an equation is exactly that symbol. So we're going to look at 5 expressions, okay? And we're going to look at the symbol in the middle. Okay? So 17 is greater than or equal to 5. Since greater than or equal to is an inequality symbol, we know that goes in the inequality box. Okay? 3x is equal to 9. That's an equal sign, making it an equation. Okay? 2x is greater than 5. Greater than is an inequality symbol, so that expression or that problem is an inequality. 2 times 4 equals 8. Again, it uses that equal sign, so that makes it an equation. And the last one, 8 is less than 3x, making it an inequality. Okay. So below, they want us to complete each inequality with a less than, greater than, less than or equal to, or greater than or equal to sign. Right? So if we know z is less than 4, if I switch around that z and that 4, I want to make it the same statement. So instead of less than, it becomes greater than. So if z is less than 4, then 4 is greater than z. Okay, so notice how it's opening up over here. That less than sign is opening up towards the 4. And over here, that greater than sign is opening up towards the 4. Okay, it always opens to the biggest number. Okay. Second one, m is less than 7. So if I reverse that, 7 is greater than m. Here it's opening towards 7. Here it's opening towards 7. Okay. G is greater than or equal to -2. So -2, here notice it's pointing towards the 2 and opening towards the G. So I have to point towards the 2 and open towards the G. So -2 is less than or equal to G to get that same statement. If you reverse the numbers, the variable, if you want them to still be equal, you also have to reverse your symbol. Writing an inequality from a verbal sentence. This is almost the same as when we were writing equations. You need to look for your keywords, right? And is still an important one, and is still important. Just now with our is, we're going to have a phrase with that word is. Okay, so let's look at the first one. The quotient of a number x and 4 is fewer than 10. So I have quotient, which means division, the word and here's my is fewer than. Okay, so quotient means division. Number, they're telling me to use x. Okay, and remember, it tells me where that operation goes. and the word is where my inequality symbol is going to go. So this time it doesn't mean equals because there's a phrase with that. So it wants x quotient 4, so x divided by 4 is fewer than 10. So it's 10 to be the bigger number, so my symbol has to open up towards that 10, giving me x divided by 4 is less than 10. The second one, the square of a number n plus 8 is at most 49. Keywords, square plus is at most, right? So here again, they told me to use n, and here's my word is, right? The square of a number n plus 8. Remember, square means we have a power of 2, so we're taking n to the second power plus 8 is at most. So that means the biggest it can be is 49. So that symbol is less than or equal to. It's at most 49, or else it has to be smaller than that, right? So when you're writing your inequalities from a verbal sentence, start just like we did for equations. Look for your keywords, look for that word is, but now your is going to have a phrase rather than a number right next to it. Okay. Then now we're going to go to writing an equality for a verbal phrase, but we're going to interpret a little bit more about what that symbol means. Okay, so all real numbers p are greater than or equal to 1.5. Right? So p greater than or equal to, greater than opens up this way, okay, 1.5. And they want us to answer these true or false questions afterwards. Okay, T for true, F for false. A real number p could be greater than 1.5. Well, if I look at this top part of my problem, it says p is greater than 1.5, so that would be true. Right? A real number p could be less than 1.5, would have to be false, because it can't be greater than and less than at the same time. And the last one, a real number p could be equal to 1.5. Since it has that or equal to line at the bottom, that is also a true statement. So equations have a solution, and so do inequalities. But now our solution is a variety of numbers, okay? It's any number that makes that inequality true, okay? So now it's not just one answer, it's always going to be more than one, okay? So here they have us check some solutions, just like we did for equations. It says consider the numbers -1, 0, 1, and 3, which are solutions of 13 minus 7y is less than or equal to 6. What they're asking me to do is substitute in these values and see if I get a true statement. So if I start with -1, we have 13 minus 7 times -1 should be less than or equal to 6. Order of operations, we do multiplication first. So I have 13 minus a -7 should be less than or equal to 6. When I minus a negative, it actually becomes plus. So 13 plus 7, I have 20. And they're asking me, is 20 less than or equal to 6? Well, that is not true. That is a false statement. So that means that this is not a solution. Okay? Because this is not a true statement. Okay? And since it's not true, it makes the whole solution not possible. Okay? If I check 0, 13 minus 7 times 0 should be less than or equal to 6. Again, multiplication first. So I have 13 minus 0 should be less than or equal to 6. Well, 13 minus 0 is 13, which is not less than or equal to 6. So that again does not work. And if it doesn't work, that means it's not a solution. Okay, so while I work through the next two, or why don't you try the next two on your own? Okay, so the next one they want me to check is 1. So I'm going to plug in 1, so I have 13 minus 7 times 1, and it should be less than or equal to 6. Okay, multiplication multiplication first. 13 minus 7 should be less than or equal to 6. 13 minus 7, okay, is actually 6. And if I look at that, since it has the or equal to symbol, this is a true statement, which means it is a solution. Okay, so this one up here does work. Okay, and the last one they wanted me to check is 3. So if I have 13 minus 7 times 3 should be less than or equal to 6. So I have 13 minus 21 less than or equal to 6. Now since 21 is bigger and it's negative, I know my answer is going to be negative, and this is negative 8 is less than or equal to 6, which again gives me a true statement. You don't have to write true, I'm just writing that so you can tell the difference as to why it's a solution versus not a solution. So since that's true, 3 is also a solution. Okay, so out of those 4 numbers, we had 2 problems that checked, giving us 2 of them being solutions and 2 of them not being solutions. So the ones that are solutions are 1 and 3.